Welcome to the presentation of integration by substitution method. My dear friend, this is the very first presentation on integration by substitution method. This is one of the very major method of integrating indefinite as well as definite, both type of the integration. All right, so please be concentrate because it's very conceptual as well as very interesting. You'll love this method to integrate the functions. All right, so I will go by first an example, and then I will go by theoretically what we do in method of substitution and what is the steps, how much steps we follow. Almost everywhere, any type of the integration you do, everywhere almost we follow the same methods, same tricks, same steps, you know, same things we do everywhere. So it's not very difficult, it's very interesting if you learn step by step. All right, so let me suppose here I'm going to integrate a function, let's say I equals indefinite integration of 2x times sine x square plus 5. All right, this function this integrand I'm going to integrate with respect to x. All right, so now what is my first step to integrate this function? Always whenever you're going to integrate any function by substitution, then always your first step is take a look on the independent variable. So first, what we need to understand by the independent variable. Independent variable are those variable generally by which you're going to differentiate the whole integrand. You're going to differentiate this integrand with respect to x. So here independent variable means this x. All right, that's your first step. Take very serious look on the independent variable x, and then you need to choose the independent variable or the expression or some function to be replaced with some other function. Always independent variable get replaced by some other function in the process of integration by substitution. All right, so either you have to replace this by supposing x, or by supposing x squared plus 5, or by supposing 2x, you know, anything you need to suppose. All right, so here now two things comes. Here we have two expression, one is 2x, another is sine x squared plus 5. All right, so which one should be replaced? Either x squared plus 5 or 2x. That comes later. I will tell you in later videos the tricks, the methods, the tips, you know, to select which one to be substituted. That I will discuss later. But that's your second step, right? Second step is here choosing what need to be replaced here. Right? So I'm here supposing here, let's say t equals to x squared plus 5. I'm going to replace the x, all the x. All right, always you need to choose in such a way, always you need to choose a new function in such a way that it can replace the whole function in the term of it. So I'm gonna replace this whole function, you know, this whole thing in the term of t. Everything, everywhere x will be replaced by t. So always choose in that way. That's your main motto. Choose in such a way that everything get converted into the t format. All right, so you may say, hey Anil brother, why don't you choose t equals to 2x? Why not? I'll tell you why not later, because if I keep on explaining the first video you will get confused. All right, so let me suppose t equals to x squared plus 5. That's my second step, and my third step is differentiate the supposition with respect to what you're going to integrate that function. We are going to integrate the whole this thing integrand with respect to x, so you need to differentiate here this t with respect to x. So it's going to be dt over dx equals to 2x. all right, and then from here I will get a result. Always and always think, always and always I will get a result, that is dt equals to 2x times dx. all right, I got a result for replacement. all right, for replacement. Now you have got like dt equals to 2x times dx, or you can write this as a dx equals to dt over 2x. That's your wish, how you want to represent it. It depends on you whether you write in this way or in this way. That's your way. So that's our fourth step. All right, fourth step, get a relationship. I got a relationship now to replace very well. And my fifth step is replacing my integral with the function in the format of the new function, in the format of t. All right, so I'm going to replace this all stuff in the format of t. Okay, so here I have 2x, no problem at all. So first I'm going to write this one, sine x squared plus 5. all right, so it's sine and then x squared plus 5. How can I replace this x squared plus 5? Take a look. t equals to x square plus 5. So in the place of x square plus 5, I'm going to replace it by t. Alright, and now it's 2x times dx. As you wish, 2x times dx is dt, so directly you can write dt. Alright, or if you want, then you can rearrange it properly one more time. It's your wish, by the way. You can write sine x square plus 5, and then you can write 2x times dt, and then in next step you replace. Or you have one more option, you can just replace this dx by dt by 2x, because dx equals to dt by 2x, and this denominator 2x and numerator 2x will cancel up, and you'll get sine square this thing t, and dt will be just left. Alright, you just replace it, you'll get it. It's very easy, you know. So fifth step is just replacing the given independent variable into the format of new function. Alright, that's it. And then very simple, just follow the integration process. I'm just going to integrate the sine t with respect to t. Alright, that's minus cosine of t plus some constant I need to put always, you know that. And then my sixth step, and that's my last step, that's replace the t, replace the new function that you had supposed with your original one. The original one is t equals to x square plus 5, so I'm just putting the value of that is x square plus 5 plus constant, and that's my integration. And these are the 6 steps for every integration process if you want to solve by method of substitution. Alright, so always keep in mind those 6 steps. Alright, the very first step I will tell you once again. The first step is look at your variable. Second step is select a new function to replace that independent variable. Third step is differentiate the new function with respect to what you're going to integrate the whole integrand. Fourth step is get a good relationship. Okay, and the fifth step is replace the integrand with new function, and the sixth step is replace the new function with original one. And that's it, you're finished. You're not finished, your question is finished. Alright, I'll see you guys in the next video. There I will tell you the theoretical portion of the substitution, what we do. Alright, till the time, please like the video, subscribe the channel, and I'll be really happy to see you in the comment section. Bye bye.